I thought it was only appropriate in this course that I talked about nuclear power and how nuclear energy was used to generate steam. So we saw how that was, because it's an important energy source. And when we think about global climate change, global warming, at that, nuclear power emits no greenhouse gases. So it's very good from an environmental perspective. The problem has to do with how you handle nuclear waste, which hasn't really been resolved, so except for active surveillance. So what we have, here's a nuclear reactor to have it simplified, and basically there are fuel rods. So I have fuel rods in here. And what happens in a nuclear reactor is that I have neutrons that are emitted, and they cause a nuclear chain reaction. So what happens is I have neutrons, they hit the uranium splits. When it splits, when the atom splits, it generates heat and generates more neutrons. And what we have to do is slow them down. So we have to slow them down so the reaction doesn't go too fast. If the reaction goes too fast, you get boom. And so we don't want boom. And so we have control rods. So part of what manages the rate of the reaction of the nuclear fuel, and so you have uranium oxide. So what happens is here is I have control rods that absorb the neutrons. So I have the control rods that I can move, and they either speed up or slow down the reaction. Now when this reaction occurs, heat is generated. So we have to get rid of the heat. So there are two types of reactors. The most popular one is a pressurized water reactor. And so what happens, and you see this is your pressurized water. And so I have the pressurized water, and I looked this up, and so typically this pressurized water might be at 315 degrees C and 15 MPa. So what I have that is leaving the nuclear reactor, and then I have to get rid of it somewhere. What better place to get rid of the heat than to have it be used as an energy source to create steam here on a vapor power cycle. So here's the steam. This is the steam generator. So my energy source is the coolant from the nuclear reactor. So I have a pump here and a pressurizer. It's complicated, but our whole theory here is that I have to get rid of this heat, I get it here, I generate steam, this steam runs a power plant, I get my power out of here, and that's the power generated. So in the US Navy, this pressurized water system is the system that tends to be used. It tends to be the more popular reactor system than a boiling water reactor, where you basically say, get rid of this, I'm going to generate steam and put it in the turbine. But then all your secondary components get contaminated with radiation. Here, you're keeping it removed from the radiation. And so that's an important feature. One of the things here is that this tends to be saturated water, the saturated steam. So if I start off with saturated steam on a TS diagram, I start off as saturated steam. Pretty soon, as I go like that, I start getting moisture. And as I've mentioned before, turbines and moistures don't like each other. So what happens is they have moisture separators, so they can extract the moisture. They basically remove the moisture from the steam, take it out of the turbine, and periodically there are moisture separators. In addition, what they can do is they can take the steam and reheat it. So when they take it out for separation, they can put it back in and have reheat go on. So then I've lowered the pressure, and I'm going to be going up like this. And so I'll be trying to add some reheat to it. So it's a little more complicated process. But this is how a lot of the nuclear reactors, the nuclear systems in the world, this pressurized water reactor tends to be the most popular one. And I thought I would explain as well. So this is one topic. One other topic as well is geothermal energy, because people talk about, let's use natural energy sources. So geothermal energy might be one. There are problems with it, and I wanted you to be aware of those problems. So this is on page 582. And basically what happens, if I look down here, and we have the magma. So this gets into more geology than I truly know, but well, I knew a little bit. I knew enough to be dangerous to write this part of the chapter. And so we have here crystalline rock. So this is the hot inner core of the Earth. So it's hot, and it's going to radiate out. And up here, we have permeable. So up here, we have the soil, and we have permeable Earth. And you'll see, and we can have rain. So rain can come down and go in the ground. So basically what's happening is we have eventually water from the surface goes down in here, and then what I have is I'm going to put in a pipe. I'm going to put in a pipe, and if I put it down there, then the water that goes down is trapped in this low permeable rock and permeable rock. There has to be a certain strata that occurs, and so then I have high pressure, high temperature water looking to get out. And that's where geysers come from. But in any case, it's looking to come out, but if I put a pipe down there, then it finds an easy way to get out. And what we have to do is control it. So now if I look at this, and I have the Earth's surface here, and I put down a pipe, so I put down a pipe, and we have a valve on it to control it, of course. It's going to come out. It'll go into a steam separator. So I'll have a liquid here and vapor here. And I'll call this 4 and this 3. And from 4, we'll go into a turbine, into a condenser, and now. So if I look at this, let me draw this 1, 2, 3, 4, 5, 6. And on a TS diagram, so here it's state 1. So at state 1 it's under high pressure and temperature. As it goes up, the pressure drops. So as the pressure drops, it's going to flash. So I flash down here to state 2. So at state 2, I'm at the surface. So now I'm at the surface, I'm going to drop the pressure some more. So here I am at 2. I'm going to drop the pressure some more, and now I'm at state 3 and 4. So state 4 is here, state 3 is here. State 3, this is fairly high brine, has a lot of dissolved minerals, salts, messy stuff. And so when it flashes, this becomes more concentrated. So this becomes water, this becomes more concentrated in terms of brine I have as a liquid. And then I'm going to, from 4, I expand to 5. And I can condense to 6. There's no cycle, so it isn't repeating itself. So then the turbine work is H4 minus H5. So that isn't much. But the question is, where are these things located? So normally they're located in areas where it's geologically unstable. So let's see, you want to put in a capital investment where there's going to be potential for earthquakes. Maybe. And so if it isn't too much. The other thing that we have to do is we have this liquid you don't want to have it go out on the surface because it would destroy everything. And I have this liquid, so they tend to be recombined and re-injected into the earth, so you don't have it as surface water, which would kill all the natural fauna. And so there are challenges with this in terms of expanding it simply where the correct geological formation is not the most stable place to put them. And so for homework, do 1564 A and B.